All right. Well, thank you all for coming to the performance measure, going with the flow visualization of transportation operations session, where we've got three presenters that are going to go through some of their operations visualizations. We're going to start off with Mark Franz. I had his bio pulled up, but now I missed it. So I'll go off memory. I know you have got a BA in physics, or BA in physics and a BS in astronomy from the University of Florida, and an MSCE from West Virginia University, and your PhD in civil engineering from the University of Maryland. You're the analyst or the lead analyst for the Cat Lab, and I can't remember anything after that, so I'll leave it to you to do your presentation. Thank you.
Thanks, Kevin.
Thank you.
All right, so just a heads up that I am going to be darting out after my presentation to catch a flight, so I'll take as many questions as I can, and I'll leave my contact information if there's any follow-ups with that. So my presentation today is on a couple of projects that we did to automate the process to identify and quantify the causes of congestion on the road network. So just to give you a brief history of studies related to this, I'm going to talk about some of what had been done before Cat Lab got involved, and then there's two separate tools and studies that Cat Lab has been involved in. The one was a national study that we did back in 2019, and we spun off of that a sort of deep dive tool so that users can request the cause of congestion results for specific road segments, custom date ranges, days of week, all those other kind of filters that you can put on. So just a brief background. If you all are familiar, in the United States, a pretty famous study that was conducted by colleagues at Texas Transportation Institute and Cambridge Systematics was to, for the first time, try to, at a national level, estimate the causes of congestion in the United States. So that was back in 2004, so that was before the era of probe data and smartphones for the most part, and so they had limited data that they could use, so they did some field studies and used simulation to scale that up to estimate what it looked like on the national level. And this was what, a graphic actually from their report was this pie chart that I copied over. So the Cat Lab initially got involved with doing this type of study initially through a grant from the Bureau of Transportation Statistics. So we worked with the Eastern Transportation Coalition and developed some methodologies that would estimate the causes of congestion on the entire national highway system. Every state that has a national highway segment in it was included. And we also worked with BTS and the Eastern Transportation Coalition to identify sources of data that were real world. So we weren't going to rely on simulation. We have enough data in this era for us to do this assessment without relying on any simulation. So for the first time that had been done, this was kind of the groundbreaking work that we were bringing with our research. So we developed the methodology, identified data sources, developed methodology, and then ultimately created an online tool, which is public access to. So I'm going to be demoing that in a few minutes, and I'll show you the functionalities that we did. So that tool covered just the calendar year of 2019. It gives you the ability to filter and dissect data month by month if you want. It breaks down the national into state and then each state into counties. So you can get down to the finest resolution spatially is a county and the finest temporal resolution is monthly. So that's a good start. People were pretty excited about that, but they said, well, wouldn't it be nice if we could pick specific road segments and custom date ranges and hours of the day so that I can look at the causes of congestion for very specific applications. So we worked with some of our partners in RIDIS, which is the Regional Integrated Transportation Information System, at Cat Lab. So some of the states ponied up some money and asked us to develop this tool, which we recently completed this summer, and we'll continue updating the new data as it comes in. So I'll demo this one as well, as you can see the results, and this is sort of what the interface looks like. You do a custom road selection, and then you get some outputs. in one of our tools. So just a little background on the 2019 national study. Again, this was the one sponsored by the Bureau of Transportation Statistics. And again, the motivation here was, the most recent time this had been done at a national level was 2004. And we knew that our interactions with agencies, they were still referencing that study to justify their investments for congestion mitigation, even though that study was done more than 17 years ago. And as I mentioned, a lot of it was simulated data, but it was the best that people had to go with. So BTS saw the opportunity to work with CatLab to update that, and again, using real world data. So that was sort of where we started with. So just a high level summary. I don't intend to get into any of the technical details. Happy to chat with anyone that's interested afterwards. But it's basically a 3-step process that we developed. So the first one is to identify congestion. And what we do is we look for a 60% of the reference speed. So once it gets to 60% or lower, we call that congestion, and it has to be sustained for at least 5 minutes. Then what we do is we activate what we call a bottleneck. And then once the bottleneck is formed, we start tracking the travel times and the queues and the speed drops in the queue to estimate what the overall delay is. And we scale that up by the volume that we have. So identify, I just talked about quantifying. We convert that to either vehicle hours of delay or user delay cost in dollars. And then the last step is to match that to a cause. So we have the bottleneck head location and all this incident data or causation data, which I'll talk about it in a moment. And we match that location in a temporal space or filter as well. And so for instance, a bottleneck occurs because there's a crash. We identify that, how much delay it caused, and we assign that dollar amount to the events category, right? So the data that we used here, and again, this is at a national level for an entire year, so it's truly a big data study. It actually took about 5 months to process the data that you're going to see in the tool. So for identifying, congestion or disruption, we used 1-minute probe data, which we purchased from INRIX. This covered 370,000 individual road segments that comprise the national highway system across all 50 states. Recurrent congestion, we just look for the historical speed patterns to see if there was, an AM, or commonly an AM or PM peak, and how severe it was. So we had methodologies in there to capture on a typical day what we expect for that recurrent congestion based on historical patterns. We also had weather data. So we used a radar readings that we developed a methodology to a process called conflation, where we take the radar readings and reflect them straight down through the atmosphere and onto the road network. And in that way, we can record the precipitation type and rate every 2 minutes from the radar. So that's what we use for our primary weather data source. Other weather data sources we use from WAZE, so things like fog, you don't get the capture on radar, unfortunately, so we relied on WAZE there, and also flooding from residual effects of precipitation. You can see here we also used incidents from WAZE. That was 78 million that we looked at. We had the national feed for 2019, looking just at the incident category from WAZE. Work zones, again, we relied on WAZE. We had to rely on some of these crowdsourced data sources because there's not a national database to date on work zones. So we had to resort to using some crowdsourced data. Holiday travel was the next category, and that's just based on the calendar. So the Wednesday before Thanksgiving, the Sunday after Thanksgiving, that whole period, if there's congestion happening, it would be at least a portion of it contributed to holiday travel. Then we had traffic signals. Again, there's not a national database, and we even learned that some states don't even know where all of their signals are, and it's partially because of the systems that they have, but there's also differences in jurisdiction. So sometimes county level own and operate traffic signals, and then local jurisdictions, cities and townships own and operate their own. So getting all that data into one database is tricky, so we had to rely on OSM to estimate where the traffic signal locations were at. We also have a category, and this is different from the 2004 study, for multiple causes. So it could be a combination of 2 or more of any of the above listed causes. And then we also have one for unclassified. Again, we're using real world data. We're not simulating anything. And there are cases where we would detect congestion, but weren't able to attribute it to a given source based on the data that we had available. So this slide just kind of shows side by side, and it's not an apples to apples comparison because we have different data sources and different categories. But you can see some of the changes. Probably the one that's most pronounced that I've been talking with people about is traffic signals. It used to be 5%, now it's 19%. A lot different than it used to be. But again, that's it could be attributed to several different things. We also see that we have all these additional multi-cause categories, which had previously never been looked at before. So that was a unique contribution that we brought to the table. So I'll jump out for a moment and demo this national level tool. Oh, thank you. So this is actually this embedded in our RIDIS system for those who have RIDIS accounts, but this particular one is open source because it was a federally funded project and we wanted to give access to a broad audience. So the tool allows you to come in and you can do, by default it shows the full year of data. You can change this if you want to months or a custom range. So if you wanted to do like the first quarter, you can do January through March, for instance. You can kind of see the pie charts updated a little bit. By default, it shows the national pie chart. So almost $10.5 billion in delay in 2019, we estimated, with the majority of it coming from recurrent congestion, right? What we can do then is you can click on any one of the slices of the pie, and it will give you a bar charts for the months that you have selected. So this is showing the trend in recurrent congestion at the national level for the months of January, February, and March, right? And it does all the same for the states that are next to it. So we have the functionality. Maybe you don't want to see the national level and you want to look at different states, and maybe you want to zoom into Connecticut, and you can hit their counties and it'll give you a list of the counties. And you can either search through them alphabetically, you can resort them by what had the largest percentage of a given category. So if I do recurrent, it'll update that to be New Haven, which is the biggest city we have in Connecticut, so not too surprising to see that. You can also switch the visualization because we do have quite a bit of categories here. I personally like the bar charts because the labeling and the layout is a little bit easier to see, and you can see how you can filter down to this level and get the bar chart view of the data. So just to go through like a few use cases of how this national level tool could be used. You can compare the pie charts for the state of Colorado for the entire year versus Arapahoe County, which is one of the counties that are east of Denver, one of the suburb counties. And then Summit County is where it's up in the mountains where the famous ski resort of Breckenridge is located. It's almost 2 miles up. So you can see, the patterns between Arapahoe and the state level look, fairly similar, with the majority coming from recurrent congestion. Most congestion happens in urban areas, so if you have one or two large cities, it's going to kind of dominate the state level pattern. But one thing that's interesting, in Summit County, again, where the ski resort is at, you can see the contribution of weather is 9%, where in the rest of the state it was 1% and 2%, 1% in Arapahoe County and only 2% for the entire state. You can also see for all of the state and the two counties showing here, there was a kind of spike in weather-related delay. So what happened here was I went back through and did a Google search and found that there was a major blizzard snowstorm that went through and dumped feet of snow in some areas, and it was kind of captured in each of the individual counties that we looked at. And then when we zoomed in to look at 1 month at a time at the month of March, you can see the contribution, especially in Summit County, even though it was pretty high before for the year, 9%, now it was 16% for that month. So you could kind of use that to sniff test and see if the data that we're using and the methodology is giving you what you would expect. So even though the national study did quite a bit to advance and update the causes of congestion, there was still a desire to look at more data and provide the ability to drill down to more specific queries of space and time. So like I mentioned, we worked with several states. We called them the RIDIS Enhancement Group that ponied up some money and asked us to develop such a tool. So some of the benefits and kind of challenges that we had to overcome is we wanted to enhance the spatial coverage. So we originally did the national highway system because that's where we had volume coverage. You need volume estimates for this type of study, and we get those from the HPMS directly. They wanted to do non-NHS segments, which put the burden on the agencies to send us volume data for those roads, which they were willing to do. Enhanced temporal coverage, so going beyond 2019. So this deep dive tool that we developed starts from January 1st of 2019, and right now it has data up through September, but we're going to be updating that on a weekly basis rolling forward. So at the close of each week, that data will become available in the tool. And we also, as I mentioned, enabled the custom spatial and temporal analysis, and we integrated where we had the data from certain states, their own incident and work zone data, which is higher quality, more valid than I think most people would accept from VIZ. So we integrated those into our methodology and the data sources. Similar data sources. The main difference here is that, as I mentioned already, the incidents and work zones, we still use the crowdsourced data there from VIZ, but we added the agency-specific data that they share with us and increased the spatial coverage. And just to give you a sense of what including the non-NHS segments do, it sometimes more than doubles the amount of available road segments that are available for analysis. So it greatly expanded the ability for the states to dig down or get results that had never really been looked at before. So the methodology was generally the same for this. We made a slight modification to our user delay cost methodology and did some validation to show that it was more accurate. And then, as I mentioned, we brought in the agency data in the categorization step. So I'll give you a demo of that tool. So this is the query page. So you come in and for those familiar with our probe data analytics suite, they're all, the query pages are mostly designed the same way, where you come in, you select the data source and the roads that you're interested in analyzing. Then you can select the date range. You can filter by specific days of the week. So if I just want to do weekdays, and I've already selected here from 4 to 7 p.m., so like a PM peak period study, and I picked the Beltway around Atlanta, Georgia in this example. But you can really search for any road where we have the data. And then it asks you to provide inputs for both passenger vehicle and commercial vehicle value of time. The default gives you the national average, but you can customize those and put them in your results. So I'll go ahead and hit submit here. And you can see it's running a full month of data for that Beltway, and we got results in a few seconds. So on the left here, we have a table that kind of summarizes what the road selection was. So again, it's the I-295 Beltway around Atlanta. It's 125 miles of road. I'm looking at just weekdays from 4 to 7 p.m. and it summarizes my my value of time and then the percentage of both commercial and passenger vehicles. And then below, it kind of gives a summary of what the overall cost was and how many events were detected during this period. So as you might expect in Atlanta, for a PM peak period, recurrent congestion dominates, right? It's almost 50% of all the congestion on that road segment, followed by incidents. Then we have some unclassified. You can also see that multiple causes, so this is the summation of all multiple causes, is about 21%. And not surprisingly, the top two individual of recurrent and incidents make up the most populated multi-cause category. So we're working on some enhancements here so that people can say, well, I think that incidents are the most important. So any multi-cause combination that has incidents, absorb that into the primary incidents category. So that's a future step that we're going to be taking with this. So jump back in my presentation. So there's a couple of use cases, but I'm going to just jump to the one I think that is most applicable to agencies. And it's kind of a two-step process. You discover the top bottleneck in a state. So we have a bottleneck ranking tool that does that. And I did that for the month of April 2022 in Massachusetts. And it was this road segment, I-93 northbound. And then I exported this. All the blue segments are the list of segments in the queue for this bottleneck. And I inputted that into the causes of congestion tool for the month of April. And you get these results. So you can see that incidence was actually a major contributing factor. But again, look at the multi-cause this time, 60%. And you see the pattern, though. The top two individual, incidents and recurrent, also comprise the largest multi-cause category. And what we're finding with our studies here is that the data coverage and quality, it tends to be better in urban areas during the daylight periods. And if you go overnight and in rural areas, the data tends to go down and you get more like unclassified category pop out. So that's the conclusion of my presentation. I thank you for your attention and the event coordinators for allowing me to present the Cat Lab's research, and I'm happy to take any questions or comments you all have.
I saw you had WAZE data in your data stream. How easy or difficult was it to procure that data set?
So because we were working with BTS, they have an agreement where they share the national data feed with the BTS, and we were able to extract that from their database and bring it over to ours. Michael, did you want to add on that?
We also have an agreement with WAZE whereby they provide their data to us for the U.S. and other countries, and we in turn provide them data from the state DOTs that we work with, so that they're increasing their own awareness of what's going on.
Yeah.
Is anyone doing anything to solve congestion? And is there like are you looking into that at all? Has anybody been successful about reducing recurrent congestion specifically?
Yeah.
Or I know, for example, Florida has a TIMS program, traffic incident management,
Yep.
where they get responders and law enforcement wrecker services all to agree to try to clear crashes quickly, for example, or other incident-related congestion relief strategies, but I don't know if it's actually working.
Yeah, so we're not quite at the point of making recommendations on how to mitigate the congestion in the categories. These tools are fairly new, so I think people are still getting familiar with them, but the hope is to navigate them to a specific cause. So when they have funding to mitigate congestion, they can target it at a specific category. So if it's incidents, like you're saying, maybe buying some more safety service patrol vehicles to put out there and clear them, or encouraging some travel demand management, trying to get people to work from home more to mitigate the recurrent congestion patterns, things like that. Yeah, and they can, so we're trying to guide them down that path, and they can discover those kind of to mitigate.
And are you looking at any of the predictive efforts that are out there that might also involve pre-placement of response vehicles?
Not part of this project, but we are working on some predictive modeling for incident duration and forecasting, so that a day in advance we can say we think that this area or this couple of segments have the highest probability of an incident occurring. So you might want to have a patrol vehicle either parked or kind of circulating that area. So different project, but we're looking at that. Yes. Sure.
I noticed that in some cases there's a large percentage of the unclassified types of congestion. I have to think that'd be kind of unsatisfying for us. But
Yeah.
DOT people trying to figure out what to do. Is there what are some strategies, or have you thought about some ways that we can try to reduce that amount of unclassified by looking into some other approaches to actually try to classify those types of incidents?
Yeah. Understand that it could be frustrating to have that as one of the higher categories. But it really comes down to a data issue. So we're able to detect the congestion, but given the sources that we have access to, the crowdsource and the ones provided by the state agencies that we partnered with, nothing was there. So, I mean, there's always probably going to be some level of unclassified just because of the stochastic nature of traffic and the ebb and flow. But I think that to address that, we need more data, better data on, incidents and things like that, with that the states can maybe address. I know that they have limited resources, but yeah, Michael, you had
But there's one agency that we work with that is using this to justify increasing their incident management reach outside of the urban area. Or if they're saying that the unclassifieds are happening between, midnight and 3 o'clock in the morning, they're using this to justify turning their operations into 24/7 as opposed to, 2 shifts or something like that.
Yeah.
For the guy who asked about Florida specifically, if you're from Florida, the first call we got about this tool was from someone in Florida who used this to justify some budget request to the state legislature. He said, hey, look, here's where the problem, here's why we're having problems on our roadways. Keep funding X, and by the way, increase it by 10% or whatever.
Okay, thank you, everyone. Oh, yeah, go ahead, Scott. Yeah.
It kind of builds on Matt's question. For those agencies that you did the 2022 study,
Mhm.
did you know, were any of those ones had low or a lot of unclassified and then jumped up significantly whenever you added the agency data? Or?
Yeah, one of the use cases that I had prepared but ran out of time kind of looks at what the addition of the agency incident and work zone data did. And it did help with unclassified, but you would think that it would make just those 2 categories jump up. And what it did, it just resorted things. So now we had a lot of the multi-cause grew quite a bit when we added the agency data into it. So it did drive down the unclassified some, not as much as we were hoping, if I'm being honest. But then it just redistributed to the multi-cause for the most part was the impact of it.
Did you see anything with construction, work zones going up? Because I know there was concern about the WAYS data not really covering construction events quite as much as.
Yeah, there was an uptick in the work zones and multi-causes that involved work zones. So we did see an uptick in both categories, both incidents and in work zones, because we had more observations. So that was an expected result. It didn't go up by as much as I was hoping, because I had some doubts about work zone data in ways myself, but it's kind of what we saw. I think part of it is where agencies can control the actual work period for the work zone. They might not be having it active during the AM and PM peak periods is maybe one way to explain that, but we'd have to look into each individual.
And I know work zone data is always an issue for agencies to collect too, so.
Yeah. I've been talking with Jawad at FHWA about this because he was asking some questions about the much lower number in our study versus the 2004. And he said they're working, hopefully within the next year or 2, to have a national work zone database. So that would be cool, but it's not there yet. Okay, thank you, everyone.
Thank you. All right, so our next presenter is Michael Pack, who really doesn't need an introduction, but he's director of the Cat Lab. And with that, I'll pass it off to you and kind of let you do your own bio.
All right. So I'm going to be talking about a project that we did for the Maryland Department of Transportation to try to combine the different modal units that they have. So whenever anyone's seen me present, I usually talk about our RIDIS platform. And the RIDIS platform is, for better or worse, it's primarily surface transportation. And so that's cars, buses, there is some transit in there as well. But there's not currently any maritime data. There's not any sort of air traffic data. And we certainly aren't looking at ports specifically, or at least we haven't in the past. And the Maryland Department of Transportation, the secretary came to us and said, I really want to try to understand how a disruption to the port, the seaport in Baltimore, affects other modes. Or if there's a weather event that creates a crash someplace on the roadway, yeah, that's impacting drivers, but how is that impacting transit? Is that impacting people being able to get to the Motor Vehicle Administration to redo their licenses? How's it affecting people getting to the airport, and how do airport operations affect all this? So trying to tie together all the modal units is what he wanted, specifically so that he could sit in his office and have a dashboard that he would put up in front of him that would show all the different modal units and how they related to one another. So that was the task that we were given. And so we went in and we worked with every mode, and we tried to pull data together and create a common operating picture for them that would break the state down into certain regions and kind of give you an overview of what was going on in the state. So if you look at this screenshot of the system, over on the left-hand side, you'll see there are different kind of tabs that you can click on. The first screen that we're looking at gives you the ability to look at different types of events. Here we've put weather, and this is an event map, and there's a transit event map over here. You could combine everything if you want to, but then it breaks the state down into different districts. And it says, okay, well, here's how many things are happening in the capital region compared to the central region. And by the way, there's something bad going on at the port. And this is a screenshot, so you can't see it, but there's like a stock ticker that moves down around the bottom that shows you the significant things that are happening. Then if you click on one of the other tabs over here, this is showing you all of the roads that are experiencing delays and why there's a delay. And this also acts like a sticker. Each one of these is a little card that kind of moves around and shows you the most terrible things happening in the upper left-hand corner, and things just kind of slide along. So it gives you stretches of roadway that are experiencing problems, and it'll show you which parts are experiencing problems, and it'll overlay whether there's crashes, or it's raining, or there's high winds, or what have you. And then by region, it gives you bar charts that tell you how much of that region is better than average, worse than average, or operating normally. And I think I took some of these screenshots during the pandemic, so a lot of things were just better they're still better than they used to be. Let's see. Then we have a section that shows you the highest impact events. And this just shows the top 10 or 15 whatever things that are going on. And it doesn't just tell you that there's a crash and that it's, affecting a particular lane. It'll also tell you that, by the way, this crash is going to impact a certain transit route, and here's how many buses are on that route, and we expect those now to be delayed because of this particular crash. Speaking of transit, you can then click down a level deeper, and it will show you some sections that tell you, okay, for the local buses operating in Baltimore or DC, here's what percentage of them are early versus late versus on time versus just out of service completely. And we show you a dot representing each and every bus, so you get a sense of how many are doing well versus not. We do the same thing for the commuter buses. These are the buses that might take you from Baltimore to DC or something like that. We've also got the light rail, metro, and MARC. MARC is a big commuter rail as well. And then if there are any particular incidents impacting certain bus lines, those pop up down at the bottom as well. This is another view. If you don't want to see all the modes, or all of the transit systems, maybe you're just responsible for a certain bus system, you can go down and look at just that bus fleet and see it, and again, see which incidents are impacting which bus routes down below. Then you can go over and look at the airport. And for the airport, we're showing you, okay, the roads leading to the airport or going away from the airport, the congestion is better than average, inbound and outbound. This road, it's worse than average, both inbound and outbound. Here's how many arrival and departing flights there are, the parking availability at each of the parking garages or decks at the airport is listed, and this is all live, real-time data. It tells you in real time how many flights are arriving and departing, and we're even calculating the wait times to get through all of the different security gates. So, general boarding, priority, TSA pre-check for the A, B, C, and D terminals. And if there are any crashes or other events near the airport, we show that. And then we've got the various Twitter feeds coming from the airport or about the airport pop up as well. And then we do the same thing for the seaport. So the seaport, there's actually several ports kind of in Baltimore. We'll show you for each terminal what the congestion going to the terminal looks like, inbound and outbound, and whether it's better or worse than normal. Then we are calculating the turn time for trucks going to the port and the queue time. And we tell you what today is compared to a week prior. So you can see if things are better or worse. And there's different security levels. And we tell you how many vessels are arriving, how many vessels are docked. And for each of the other terminals, we tell you how many berths are available and what the traffic is like going to and leaving each of those terminals. And all of that is done in real time, and we archive it. And then you put it all together, and you've got this dashboard that you can put up in your office on a big screen or in your operations center, trying to move away from the, just looking at CCTV cameras and looking more at the entire system status. So this is what we have done thus far, but we've just received another set of funding from the State Highway Administration to go in and add more to this. So what do they want us to do? They want us to look at just mobility trends in the state in general. So if you saw me give a presentation yesterday, I talked about a COVID impacts dashboard that we had put together where we showed like social distancing index and how many people are traveling in each county for each day during the pandemic and how that changed over time. They'd like us to reinvigorate something like this and add this to the dashboard. So imagine being able to go in and see, okay, today we've got 5 million people that are traveling in and out of the state of Maryland. And here's where they're coming from, and here's where they're going to. Here's the top 10 destinations today, or here's the top 50 trip purposes, work, grocery, bank, that sort of stuff. Or of all the trips today, here's how many of them were less than a mile or longer than a mile. This is kind of what the system looks like. Let me just hit play real quick. Again, doing screenshots. This is looking at the entire country. Let's jump down to individual counties. Give me just a second. Here we go. So being able to see every single county and clicking on any county and seeing those mobility statistics, we're going to work to add this into the dashboard that I just showed you. And it's a tremendous amount of data. It's way more data than you get for like how many airplanes are landing someplace, right? It's millions and millions and millions of data points to process. But that's going to be added later this year. Now, the other thing we're going to be doing is adding information about overweight vehicles. So Maryland, of course, like any state, has a bunch of weigh stations. But in addition to weigh stations, they also have weigh in motion sensors. I think they have maybe 20 or 30 of these scattered throughout the state. And so we'll add to the dashboard real-time and historic weight restrictions and violations. What does today look like compared to last week? Are we doing better or worse? Giving you just individual numbers for those weight issues, or being able to look by hour of day for the last week and see how many violations there have been, and this can help them to target their enforcement activities, figure out where they should be focusing. And I'm using vehicle weight as the example here, but it can be unbalanced loads. It can be speeding violations. It can also be over height violations. There's all sorts of things that these sensors pick up that we're probably going to add to this. We're also going to be adding energy consumption and emissions to the dashboard. So you'll be able to go in and look at any road or corridor, and we'll tell you right now, here's how much, how many BTUs per hour, and compare that to the historic energy consumption, and then even predict what we believe the energy consumption will be in the next couple of hours and whether that's going to go up or down. But also having emissions data and maybe even excess fuel consumption can be on there, attributed to delay and all that sort of stuff. And this requires getting from the Motor Vehicle Administration registration data, so we know what types of engines are out there, how many of the vehicles are diesel versus plug-in hybrid versus full electric, and that sort of stuff. And being able to look at this over time. So this is a matrix where you see by day of week and by hour of day how much CO2 emissions there are, or again, we'd have other energy measures up here as well, and adding that in. Mark Franz just gave his presentation on the causes of congestion. We're going to add the causes of congestion into the dashboard as well. So you can say, hey, for the last hour, here's why the roads in Maryland were congested, or what this beltway was doing compared to this other beltway. And not just the hour, but last week, last month, so the state can figure out where it needs to invest in its resources. But all of this, once we're done, will not just be used at the secretary's office, but each of the modal administrators will have access to it. And then it will also be accessible to all of the operators in the operations center. And again, we're trying to get away from just having CCTV video up on these screens, but have larger performance indicators to try to target different operational strategies throughout the state and try to tie everything together. And that's what we're working on right now. Any questions? Yes.
Super impressive. So going to this question about addressing a problem, and I know this is real time, but could using this data, there's a location with congestion, and a project is planned. The project is planned to address that congestion, and then look to see the results of that project, right? So the project was planned to relieve congestion or cover a couple of other objectives, and then would this data also would this system also be able to then look back 3 years after or 3 years before and then say, was that project successful?
Yeah, good question. So the dashboard itself only shows real-time information. However, we archive everything. And in the RITIS platform proper, we have all sorts of tools that let you go back and recreate anything in these dashboards for the past, so you could do like a before and after study pretty easily. And there are agencies that are doing that with versions of this today. Any other questions?
So, I guess it sounded like this was a request from the secretary.
Started out that way, yeah.
So, did you get a sense for kind of how it's being used? Like,
Well, the guy that requested it's gone now. So now there's the new guard that stepped in. And so what's happening is it's moving away from just the secretary's office, and now it's working its way down to the actual State Highway Administration and the Maryland Transit Authority and all the different modal units, which is what we wanted anyway, right?
It's like kind of information overload for a director to see
Yeah,
real-time incident data or whatever. Like,
agreed. So who knows? Maybe that was his plan all along, but that's how it's worked out. Yeah.
So speaking about the next steps and before mobility data, are you already have that data? Is that something that you would like leverage, like some of the open source, or like, I mean, I know like Meta has the mobility data, and they also have like a commute data. Is that something you intend to leverage?
So all of the data and stuff that I showed you up here, we already have, and it's not open source for us. You know, the state of Maryland is paying for it in some way, shape, or form. But we source the mobility data from maybe a dozen different providers. These are like raw data providers. It's not NRIX, it's not TomTom. It's here. It's like, you know, mobile device data, and then we fuse all these different sources together, and then we have algorithms that say, okay, well, this trip looks like it's a transit trip because of its behavior, because of where it started, because of where it went, or a biking trip, or a walking trip, or a vehicle trip. You know, we got methods that do all of that behind the scenes. We're the ones that are producing the National Household Transportation Survey, the NHTS, now using this data, the next gen of it. Yeah.
So the secretary asked for it, so it's okay. A lot of times we see a nice dashboard, oh, that would be useful. We think we could use something like that. Might help with, you know, systems, management and operations. But a lot of times someone in that area will say, well, what's the use case? What problem are you trying to solve?
Mm-hmm.
And then once they get it, they go, oh yeah, this helped us solve lots of problems. Could you address that,
So-
kind of contradiction in using some of the visualization tools that are becoming
Mm-hmm. Yeah. So the original request came out of a disaster that happened in Maryland, where there was a really big snowstorm that shut down roads, and people got stuck for 30 hours in a snowstorm. And it wasn't just individual vehicles; it was transit, and the airports got shut down, and they wanted to be able to monitor how long it was taking to get the system back up to normal operations across all the different modes. And so that was the impetus for this. Now, you don't have a massive snowstorm like that every week. And so what we're doing now is working with these different administrators at the different modal units to try to figure out what are the problems that you really care about, what are the questions that you have that do happen every week, so that we can make sure that this isn't just shelved until the snowstorm happens and you don't really remember how to use it, right? And we're still trying to figure all that out, but it is being used. Yeah. All right, Nicole.
One minute while I get my computer plugged in.
I'll argue by the way here.
Sounds like a plan.
I'll actually have it all correct now.
Right?
So for our last presenter of this session, we've got Dr. Nicole Katsikides.
Perfect.
And she's a research scientist and project manager for TTI. She has 20 years of transportation policy and economic development and planning experience with significant accomplishments in freight, policy, planning, and operations. Her areas of research include freight mobility and supply chain analytics, data for decision making, public policy analysis, roadway and aviation planning, policy and operations, land use, and economic development. Prior to TTI, she served as Deputy Director for the Maryland Department of Transportation State Highway Office of Planning and Preliminary Engineering responsible for data collection, analysis and strategic planning divisions. She was a freight performance program manager for FHWA's Office of Freight Management and Operations. And prior to that, she served as MDOT's Director of Freight and Multimodalism, responsible for freight planning, policy, and oversight of the state's short line railroad. She's also has many years in community planning, economic development, logistics, policy, and analysis.
Thank you.
Back to you.
All right. Hi, everyone. I'm very honored to be here to be speaking. We've got the Maryland thing going on today. I'm a Marylander, so I'm really proud to be talking about Maryland, even though I've temporarily lived in Texas for a couple years. So what I'm going to show you is not as much an operations tool, but it's more of a planning tool that it's based on historical data that Maryland wanted. And this too, like what Michael was talking about, was born out of a need, something that happened at MDOT where they were like, we need this. And so, but what's important is, even though it may not be like real-time operations, it's important to have the historical data. And the key thing about about this tool that I'm going to talk to you about today is that MDOT has all states, they have to respond to federal highway, and they have the Highway Performance Monitoring System network. And so the state of Maryland has their official highway network, and they call it One Maryland, One Centerline. In Texas calls it Rhino. So I guess every state has a different name for their highway network. But in Maryland, they had been working on some data governance work and trying to get everything aligned to One Maryland, One Centerline, so that they had some planning tools that could help answer questions about performance and to try to get data all together. And that's really where this tool was born. And I'm still, even though I'm at TTI, I still support Maryland DOT about 50% of my time. So I'm embedded with them and do a lot of their freight and performance analytics work. So that's why I have many presentations that are Maryland focused, because I'm still doing quite a lot of work for them. They couldn't get rid of me. So what is MRPT? Like I said, it's a tool for visualizing all traffic and freight information. And it's aligned with their Highway Performance Monitoring System network. And that's important because they have to submit information on that network every year to Federal Highway. And they put a lot of data on that network, and they are aligning a lot of things to that network so they can see it all together. They have a single point of reference for the information that they're working with. The tool, one of the things that they wanted was tell us what our top bottlenecks are, help us understand our bottlenecks. And there's a couple of reasons for that. Every year they have been reporting a mobility report, and they were ranking bottlenecks in particular ways. And they wanted to evolve that mobility report a little bit. So they had asked for us to put congestion information from INRIX XD data onto the HPMS network so they could see things a little differently. And the other reason is that MAP 21 has performance measures that states are required to submit, and for freight, they need to submit their freight bottlenecks and have some intel on what's going on. So they asked us to do all this and create something where they could see the performance statistics on their network, the HPMS or One Maryland, One Centerline, on their network, and they wanted to be able to see other types of performance measures. They wanted to be able to see it at different geographies too. So they didn't want, they wanted to be able to zoom in and zoom out, and they wanted to know who owns the road, where it is, the functional class, and is it on the National Highway System, is it on the Strategic Highway Network, or other things about it, so they had some good intel. So the tool that I'll show you in a little bit here includes a suite of measures, and the data are all aligned to their HPMS network, so they can put anything from HPMS into the tool, and we continue to work with them to try to add some measures. What you saw from Michael and Mark, those are really critical tools for Maryland DOT. When I was there, used them a lot, and so this initially, in the initial conversations, they wanted us to give them something that could be put into Redis, and maybe one day it will be, I don't know. But for now, they have been kind of exploring what they can do with meshing HPMS data and the congestion data, and kind of getting their heads around what conflating data looks like and the stories that they can tell before they figure out what kind of planning stuff they might like to go to University of Maryland and have them add or different things. So that's been the discussion that we've been having, is how to make tools and resources real efficient, because there's a lot of people that, having been in their shoes at a DOT, there's a lot of firms and things that come to them offering them different tools and resources, and it's really important that there be a tie back to the network, or that there be things all in one place, or that everything is together. So it's important that these tools all work together, or be combined in some way at some point down the road. Let's see here. There's something else I wanted to mention, but it's slipping my mind. So why, I kind of already went into the why here, but a lot of times for a DOT, they're always called upon to justify things or to provide information. And it's really hard to engage stakeholders, especially constituents and local governments and people that are critical to the decision-making process. And I was reminded, I was looking on LinkedIn today, and I saw that Maryland DOT, like many states, has to go around and they do what's called a tour meeting. And they go to each county and they talk to them about the types of transportation priorities that they are budgeting for that year. And Maryland's in the middle of doing that. And for the longest time, the tour meeting, and I used to go to these because I had the freight components, had this gigantic book, and it was all of the different line item budget items, and you'd sit there and walk through them with the local governments, the counties that were impacted. So every county got their own meeting, and the secretary goes, and all of the heads of all the different modal administration go, and then people who are in charge of different components, like I was with freight, go and have to, talk to the counties about what's going on. And they're using geospatial information now to try to map all of those projects, because visualization really helps people to grasp what's going on. And so that it helps to tell the story. I think you all would probably agree, because you're all here because you're interested in visualization. But it's so important anymore to, instead of having these static reports or papers or things, to have something that people can grasp, that people can digest, and that, some of these things are not easy to discuss with local governments, like truck parking. And those of you who heard my spiel yesterday about truck parking, that is notoriously challenging to discuss with local governments, because generally their constituents don't want it, but pictures speak a thousand words, and it's easier to engage. So that's really what MDOT was trying to do, and that's what they're still trying to do. And this is kind of in beta form. It's nowhere near as slick as the things that you saw previously, and maybe one day as they figure out where they're going with this, it'll evolve into something like that. But for now, it gives them information at their fingertips, because a lot of the other thing that they get often is a last minute, the secretary is going to want, tell me what's going on this corridor. I have a meeting with so-and-so, or I got called by this elected official, and I need to know what's going on US 50. I need to know what's going on 13, or the Aberdeen mayor called, and he or she's upset about this and what's going on. And so they need to kind of have some historical information to understand what's been happening, what do things look like up there. And congestion is just part of the story. So that's where the thought was, if we had something where we could see everything together in our data set on HPMS, we could give the secretary or the state highway administrator a little more intel very quickly at a click of a button, what's going on, and whoever that person is can answer questions or engage or get back to the media, or just have intel as they're going up to any kind of meeting. So that's really where the focus of this tool is, or why MDOT was having us put this together. I'm going to drive you through the tool, and I recognize we're probably getting, I don't know if you've got a little bit of time, but I'm going to drive you through the tool, but a couple of snapshots here. I mentioned the bottlenecks that they have to report on. And so the first part of the tool mirrors what TTI in the past had done for TxDOT with the Texas 100. And I don't know if any of you are familiar with the Texas 100, But that was a way, it was legislated by the Texas legislature to always to report on top bottlenecks. And over the years, it has evolved from all traffic bottlenecks to freight bottlenecks as well. And it provides a suite of measures. The bottlenecks are ranked by delay per mile, which has been an industry standard measure that people are using now, and also the Federal Highway Freight Mobility Trends tool that my team and I worked on for Federal Highway ranks the national freight bottlenecks by delay per mile. So for MDOT, we gave them smoothed out all traffic and truck bottlenecks, and I'm showing you an example of the truck bottlenecks based on delay per mile. But when you get into the tool, and I'll show you this, you can rank them by other measures as well. So even though it might, on the tool it says top 100 bottlenecks, we actually smoothed out over 800 segments to try to put them into logical segments. So MDOT had a good idea of the bottlenecks and how they're changing year to year. Excuse me. And we provide a lot of detail on that, and it's probably best to just show you that in the tool. We've been able to code into different networks that MDOT cares about. So for example, the freight network is important, and they're monitoring the freight network and continuing to work with MPOs, metropolitan planning organizations, to talk about critical urban and critical rural freight network segments. And right now with IIJA, the states are in an exercise to add to those segments. And so this tool is helping to see what the performance looks like on the existing network and help to identify new segments or have those conversations with the MPOs. But we've been able to code in different networks, whether it's statewide, region, freight network, or some critical corridors that MDOT cares about, and we can see them. Before I want to show you the tool, but one thing that is useful, and having been there in their shoes for many years, sometimes you need something quick, like I mentioned, or you need to do something kind of custom, and it can be a lot or time consuming or expensive to dial it out to consultants. No offense to consultants all the time, but sometimes you just need defensible answers at your fingertips. And so that was really what was behind this information. And recently they had an exercise that they needed to know suddenly, because we have lots of measures in here, and one of the measures that I'll show you is CO2 on the network, historical CO2. And it was like, what's been happening over the years? What are the top segments for CO2, normal CO2 and congested CO2 over the past couple years? And so we were able to use this tool. We were able to run the measures in the tool and then download them into Excel the way we needed them, and then put them into Tableau very easily. It took less than an hour to come up and make a little Tableau dashboard for them that suited their needs for a last minute meeting. So we just kind of threw the information into Tableau and organized the buttons the way they wanted. Like I said, this took less than an hour, and it's not expensive, and it gave them a snazzy little tool that, and I'm not going to demonstrate this one, but the point being, they had all the information aligned to the HPMS network. So we were able to pull it out very quickly, throw it into Tableau. We also threw it into ArcGIS online for them, into a story map. And you can do these things really fast and get them something that they can go in front of leadership with and have something other than a static piece of paper. So that was important to them. All right, let me show you the tool. I'll kind of drive you through it a little bit. So when you land on the tool, it defaults to the top 100 bottlenecks. And so these are already smoothed out. MDOT can go down to the bottom here, and they can print out whether they want 5, 10, or more bottlenecks. So if they get a reporter calls and says, I'd like to know where your top bottlenecks are, they can spit this out here quickly, and it shows the historical information over time. They can select right now. One of the limitations of the tool is that there's only 3 years of data in it right now because it's aligned to HPMS. And if you're familiar with HPMS, it's kind of a year behind. So they just turned in the HPMS data for 2021 to Federal Highway highway in June. I believe that network is almost out, and as soon as we get that network, we'll be showing 2021 in here as well. We're also working on an estimated network, so they have 2022 information or something close to it, so that they have something a little bit closer to now, because obviously 2018, 2019, and 2020 are kind of dated. But again, this is looking back and seeing how things have changed over time, or looking at, you know, what happened year to year, so keep that in mind. So like I said, it defaults to the bottlenecks, and you can go down and click on different things. I wanted to show you one thing that's kind of irked me over the years, especially as someone who ran the freight office, was when somebody would say, well, all bottlenecks encompass freight, so we just need to focus on all bottlenecks. It used to drive me nuts because, and this is something we've seen in Texas 100, we've seen it in the mobility work we've done for Federal Highway, and I see it in Maryland. The bottlenecks that trucks experience are not always the same as those for all traffic. And I'm going to show you this highly sophisticated back and forth here so you can see what I mean. So this is all, and I mean that as a joke, this is all bottlenecks, all traffic, and when you switch it to trucks, I don't know if you caught that, but see how it changes a little bit? So you can see that there's a difference. So I'm going back and forth, so highly sophisticated. And that's important because, and I'm sorry, I'm a freight person, so you're going to get a freight earful. If you don't consider the freight bottlenecks, or at least look at them or look at the lens, you might be missing important opportunities to fix something that could really help businesses in your region, or contribute or support a lot of jobs for people. And, you know, constituents living in the state, they don't, you know, they always say like freight doesn't have a voice, and people talk, and so you hear a lot more about transit and things like that. But if people could make a connection to the fact that, you know, the freight bottlenecks and all, and have an impact on jobs, and that's something we're trying to do in some of our other work with like freight fluidity, perhaps maybe there would be more support to alleviate some of the freight bottlenecks that are out there. So it's important to be able to have this kind of information. When you're looking at the bottlenecks, one of the things you can do here is look at the map focus, and so you can recolor these for ranking at, you know, just at a click of a button. So you can see by changing, or you can, like, for example, we have these other measures in here. You can do it by commodity value, so you can see the segments with the highest commodity value. And I'm sorry this isn't zoomed in, but if you were to zoom in, you'd see that this section up here in 95 is extremely important. But by having these different pictures at a click of a button for this historical information really helps them to paint a picture of what's going on, or to support various planning studies. And so this information can be changed. And this stuff on the left that you see, where you see the route ID, is just where I had my cursor last. So you can look at the particular segments and get information. And if you're interested in that particular segment, you can switch it to truck and see what's going on. And you can also do it by direction as well. The other thing you can do with these top bottlenecks is you can click on ones that you want to see in particular to monitor them. So if you were interested in one, and I realize the map is kind of small, but if you were interested in just a few key segments, you can click on them and add them to this section down below, and it's going to, and because these bottlenecks are smoothed out, it's going to give you the sub segments that are part of that, and give you all the information for those things that you might want to monitor. You can do a summary as well, and I'd like to show you that there's other measures in here. You can select, we have these all performance measures, so you have delay, rank bottlenecks, different measures like planning time index, travel time index, cost of congestion, but we also have the truck metrics in here as well. We try to estimate the federally mandated truck travel time reliability measure, but that's calculated different. And we told MDOT that, but they still asked us to put that in here because they use RIDIS, the RIDIS easy button to calculate that, but they still wanted some sense of what was going on, because one thing that they're doing is using this to try to dissect what is happening after they see the easy button result. For those of you familiar with the MAP 21 measure requirements, once they see what their TTTR truck travel time reliability measure looks like. They can go into this and look back and see what might be fueling that result. And then they can use RIDIS to get even more granular and kind of monitor and see what's happening, so they can make some either capacity changes or operational changes. We include commodity value that's based on the freight analysis framework from Federal Highway, and I understand soon to be BTS. And we also include some measures from HPMS like pavement. We are going to be including more of those HPMS measures soon. The other thing you can do is it's tied to Maryland's geospatial program, and they have lots of different layers that they're maintaining. So all of these layers that you see here are directly linked to M.SHA's geospatial. And we can turn on, one of the things we experimented with is having the crashes in there so they can see things in relation to freight crashes. And we'll be adding in some of these other contextual things, but we started with these so we can light up the freight facilities and things like that. Again, this isn't for just freight, but it's for all traffic as well, but we have a lot of freight stuff in there because they wanted to use it for their statewide freight plan. You can export it by clicking on this button. It gives you an Excel output. And then you can go into different regions if you want. You can go into like just a particular area and see what's going on. If you do that, and I'll promise I'll wrap it up here in a second. If you do that, let me let it load. It does take a minute. Oh, there it goes. If you do that, you can sort it by ownership. So all of these different options, state highway, county, other state agency, toll authority, national parks, Corps of Engineers, whatever it is, you can show just those segments. And so these aren't just the bottlenecks, these are all segments. So I'm into the all segment portion of the resource. You can sort it by functional class. You can sort it by one thing like ownership and then functional class, urban code, national highway system, STRANET, and then the old national truck network. You can, and then when you summarize it over here, you can also group things. And I like this because, for example, if I wanted to summarize one total for the whole Baltimore region, the math is all in there, and they can get a total for 2020 in this example for Baltimore. So these would be the performance measures for just the Baltimore region. Or you could group it by any of these other things. So route ID is the basic HPMS ID, but you could do it by ownership, and you could see the performance by ownership. So you can see that you have all these different owners on the side, and you can see the performance measures like person hours, all of these things by the different the owners. So anything that you can sort it by, you can also group it by and get one measure or one set of measures for any functional class or jurisdiction, county, urban area, and that's very useful sometimes, especially if you're in the business of doing performance reporting, high-level performance reporting. And in Maryland, they have what's called the managing for results, and they like to have high-level measures. Or if you're needing some context for how maybe the urban areas compare to the rural areas, this tool has a lot of intel to help you do that. The last thing I want to mention, I won't go through all the rest of this because it's kind of the same thing, but I showed you some of the functionality, is we make available all of the information downloadable in shape files. So if you wanted to get all of the data behind it, you can, and then you can throw it into Tableau or ArcGIS and make a presentation that you want to tailor. So I showed you my please hurry up and get us something for CO2 example in Tableau, but if you want to do anything else, you could sort it by any of those other measures that you want. And so that's our tool, and thank you for the opportunity to provide some information on it and why MDOT wanted to go this route with this historical information for their planning purposes. So any questions? Everybody's hungry. All right, yes. Mm-hmm.
So you talked about HPMS data. Do you plan on adding additional attributes?
Yes.
You've got other, outside of just IRI, a lot of other attributes there. So what are kind of your future plans?
Yeah, so they want to add, they pretty much, well, it kind of gets back to that conversation we were having earlier about use case. So it's like, well, what are you going to use it for? Like, what do you really want to answer? And so we've been looking at the different attributes and trying to understand which ones are. I mean, it's very easy to add a column with the data, so that's easy. So I think they wanted to add a couple of the more elements like the bridge information, some other contextual information that's in HPMS. And so those are the plans going forward, just to kind of have like, they wanted everything in there, and so we're trying to put them into groups though, and try to figure out like what they're going to use it for. So, anything else? No? All right. Well, thank you very much. I appreciate the opportunity to present.